Buenos dias. Just a question before we start. It will be from private session, so that's cool. Who already done some web scraping, data extraction, so getting data from website? Yeah, some of you. Did you face already some CAPTCHA? Yeah, I saw Javier. And did you try to understand how the CAPTCHA work? Yeah, a little bit. Okay, we will speak also about that. So, my name is Fabien Vauchelles. So I've been deeply passionate about web scraping for years. My enthusiasm led me to explore the fascinating world of proxy and anti-bot systems. So I'm also the creator of Scrapoxy. I assume that most of you get some stickers. I saw some of you don't have. So Scrapoxy is a free and open source software you can download and install. If you are doing data collections, it will help you on the proxy side. I can do a demo after if you want. So it basically starts proxy on cloud provider and also root on proxy services. It's a main pain when you are doing web scraping at scales. So it solves this issue. I write the software 8 years ago. Many companies are using that. So now I've got more than 200 users, company in fact, and they exchange a lot of data with that. So I'm pretty happy for this software. So before we dive into our discussion, I would like to share with you a little story. A decade ago, I was discussing with a friend of me who worked in the HR industry. So it was a time when there were very few AI and we were just only speaking NLP. But it's always a pain to recruit people in the IT industry. So our idea was, can we identify candidates in the IT industry? It could be a good project. So what if we could identify them, predict if they will leave their job in the next 2-3 months, so we could reach out them and offer them exciting job opportunities. So that was clearly an excellent idea. To be honest, that's something that can work. I tried that, trained on millions of profiles, it worked. So if you want to try, it's a good project. But to do that, you need profiles. You need millions of profiles. So we thought, okay, let's go and gather them on some website on the internet. So the idea was interesting, but I quickly hit a wall. I tried to collect hundreds, thousands of profiles, but I were blocked. So I was new to web scrapings. So I check on Stack Overflow for solutions, and the answer say, hey, Jude, use proxy. Okay, but there weren't a lot of proxy companies at these times. And proxy companies were very, very expensive. And clearly, I was very poor at this time. So when you are doing some side project, the first thing that you will do if you need some VM, you go on Amazon and you start a VPS. So I install some script proxy, get a new IP address, and continue to collect data. So I continue to get 100 and a little bit more profiles, but I was blocked. So how can I get many fresh IP addresses? And the idea came into the form of a basic trick. By destroying, installing, and creating the VM automatically, you can scale that, and it was a birth of the Scrapoxy project. So yes, it worked a little bit, but the thing is, using VM from cloud provider doesn't prevent you from being blocked. And there was something I didn't understand, something known as the Turing test. Who knows what the Turing test is? Yeah. Some of you? Turing test? Yeah, some of you. So let me give you another examples. So when I came to this conference, I purchased a flight ticket online. So it takes the form of this interaction. So, hey, I'm a new man living in Paris and I want to go to Malaga. So I will buy a round-trip ticket during the evening using my Mac, and I use a DSL connection, so I'm browsing on Safari. So this interaction is a natural and fluid interactions. But when you are doing web scraping, it's more, hey, I'm a framework in the data centers in Ireland, and I'm not interested to this conference. So my goal is clearly to retrieve thousands of prices from many airlines. I'm accessing to data with a deep link at 2 a.m. I'm inside a Docker with a Python script, and to fool you, clearly, I will randomize all my parameters to seem like humans. Okay, that's web scraping when you start. And clearly, the anti-bot system understands that because it's not organic, and the anti-bot system and the website block you. So you see, they are conducting Turing tests on your behalf. So it's tests that can detect you from a bot or users. And these tests are changing every day. So now the question is, how do anti-bot system assess us? So they meticulously analyze each signal of our browser stack. We will speak about the browser stack. So they start from our IP address to know where we are coming from Spain perhaps, or perhaps either way. They check about our protocol detail because it gives details about configurations, browser, operating system, whatever. And they execute JavaScript too, so they can know our configurations. And also they track our behavior patterns, so they know how we act on websites. And they cross-check every signal to know if we are really a bot, if it's consistent, if we are humans. So what I would like to do with you is to go in these layers so we can better understand how they track us. So the initial layer is the IP address layer. The IP address layer is a gold mine of information. This is the very first piece of information a website obtains when we establish connections. So are we accessing from an internet box? Are we accessing from a mobile device? Or are we accessing from a data center? Also, if we are purchasing a ticket from Paris to New York, is our connection originating from Pakistan? Also, if we are using US IP address, is our time zone settings on the browser set to Western Europe? It can be clearly inconsistent. Also, if we check on the protocol headers, it's very powerful. So there is 3 types of protocol headers. So TCP IP headers, there are TLS headers, and also HTTP2 headers. So first up is the TCP protocols. Who knows the TCP protocol? Everywhere, everyone, I assume, okay. So the RFC describes how operating systems should implement the TCP protocols. But in practice, each operating system has its own implementations. And even between the same OS, between the different versions, there is different implementations. So if you examine all the headers and use some statistic algorithms, you can deduce which operating system is sending the packets. Second up is the TLS protocol. So the TLS stands for Transport Layer Security Protocol. It's an encryption protocol on top of the security of the TCP protocols. And it's used everywhere. So here is an overview of how it works. So when a website wants to establish a secure connections, he will initiate a handshake protocols. And during this process, the client sends a client hello message to the server. And this message contains the list of encryption algorithm plus options. So the server receives that and selects the most compatible and secure protocol, and they initiate a key exchange, and they encrypt the connections. So This is where the magic unfolds. Each browser has its unique list of encryption protocol plus option. It's called the cipher suite. And we can make a fingerprint of this cipher suite. It's called the J3 fingerprint. And this fingerprint was invented by Salesforce. And if you are looking this protocol, the cipher suite, you can deduce, so is it Chrome sending the packet? Is it Firefox? Is it Edge? Or is it a Go library? Is it a Python library? Is it a Node.js library? So it's automations. And also there is the HTTP2 protocols. It's quite the same than the TCP protocols. So browser implementation introduce variation on headers, priority flags, whatever. And if you are looking statistically to this information, you can deduce which browser is sending the packets. So now I think you know where I'm heading with this, even if it's in the morning, okay? So imagine that you're claiming to be Firefox on Windows, but your browser stack say, hey, you're just Chrome inside a Docker on Linux, okay? Clearly the anti-bot understands that, and it could lead to a ban. So also it doesn't end here. If you look at the HTTP protocols, you can fingerprint the HTTP headers. So this is a tiny function from a well-known anti-bot system. It's for Node.js server. The code is public on the internet. You can find it. But when you read these functions, you understand the power of these functions. Because the function gets the list and the order of headers of a request. Because when you are developing scrapers, what you are doing, you're just looking what are the good headers for the API when you are doing some reverse engineering. And you remove what's useless. Okay, it's for maintenance, so it's better for your coding, so that's cool. But when you read these functions, you understand that even they are not useful for the API, they are very important, they are crucial for the fingerprint process. And if you are using this function for an anti-bot, you can clearly ban most of the web scraper in the world. Also, if you know that browsers are executing JavaScript, it is truly astonishing how much information they can get from JavaScript. They can get information like your time zone. They can get the GPU model. They can get the GPU fingerprints, so they can check consistency between two informations. Also, they can get the number of speakers, the model of speakers, the number of microphones, the number of camera, if you have a battery, so are you a mobile phone or a laptop? They can know also the list of phones. So you can detect the operating system with the list of phones because it's very specific. They can get also the list of extensions, the list of plugins. They can know if you have an ad block. They can know your real IP address if you are leaking that with a WebRTC leak, which is very common. And also they can get the size of the screen so they can detect if you are mobile just with this kind of parameters. And if you are running on Android, you can add a lot of more informations. They can know if Android debug is activated. So who is running Android debug every day? No one, unless you are doing reverse engineering. Also, they can get the architecture of your mobile. So are you using ARM architectures or are you using Intel architectures? Emulator run on Intels. So clearly it's reverse engineering. They can get also the mobile device, the names. They can get the name of Android, whatever. And on the latest Android version, there is a unique ID installed when you buy your phone, the constructor install Android, and there is a unique ID installed. So they barely can track you everywhere. And clearly, they add a layer on top of that. So the game is finished. Clearly, they track how we act on the website. So they track our journey on the website. Do we initiate our journey by a search query? Or do we just writing the deep link of the items? Who knows the perfect URL of Amazon's? No one's, okay? So if you are just writing directly the URL, you're a bot. And also they check if you are executing JavaScript, loading CSS, or just fetching HTML. I'm not reading HTML at the morning, so yeah, that's difficult. Also, they track the timing of between web pages. If you are just using a delay of 5,000 milliseconds between web page, you're not humans, clearly, unless you are very strict, okay? Also, they track the delay between mouse click, events, whatever, and they track also the movement of the mouse, because humans tend to move the mouse in a natural, fluid manner. It's a basic curve, but bots are doing like that, straight-like movements. And clearly, you can identify that. And they send all this information at regular intervals. So that's why sometimes when you are writing a spider, you can collect 1 page, 2 pages, 3 pages, and you get a CAPTCHA. That's because your reputation score gradually decreases over time and go below thresholds. And the anti-bot system say, hey, suspicious connection. Shall we send a CAPTCHA? Or perhaps directly block the connections. And of course, they cross-check all the signals and they blend that with AI. So they create a binary classification score, basic stuff, to be honest. So they can use all 1,000 signals from the previous slides. And also they can adapt over time. So they use reinforcement algorithm, like a basic also algorithm like CatBoost. And yeah, so are you happy to be tracked like that? Yeah? A little bit afraid? Yeah, okay. But we can bypass that. That's the good part, because there is a weakness, and this weakness is a conceptual weakness. It's called false positives. So let me give you another example. That can happen to you. Who is using Linux? Okay, some of you, so that's cool. So if you are using Linux, and perhaps you're going on some Iberian companies, you know which ones, you cannot buy the tickets. I cannot buy the ticket from France with Linux. I have to switch on Windows because the antibot is raised too high. And what's happening when I want to use this company, I just switch to a competitor website to get my tickets. So they just lost the customers. And that's what we call false positive. That's the main issues. And it happens all the time because when they set antibot systems, they raise too much the security level. So after that, they need to lower. And when you are running a business, false positive are something that you want to avoid at all costs. You don't want to lose customers. So there is 2 approaches to set up correctly an antibot systems. The first one, if you want to use all the 1,000 available signals, that can be very difficult because you need millions of clean records for each signals, correctly tagged. It's machine learning. Of course, it can be very challenging, very difficult. So what you'll do is reducing the number of signals to the effective ones. And furthermore, there is some signals that can be very difficult to get, like the TCP signals, because you need to be root, you cannot get them on Kubernetes, whatever. So nowadays, commercial solutions track between 100 and 200 signals, and mostly based on IP address, HTTP headers, JavaScript executions, and behaviors. So now our objective is to understand which commercial antibot you have in front of you. And to achieve that, there is very cool extensions. Who know Wapalizer? Some of you. So that's a very cool extensions because it gives you all the technology of the website, especially the security technology. And when you found that, you can open the Chrome Dev tool on the inspectors, and you have a lot of requests. But the creepy request, the strange request, will be the antibot because it's encrypted and so on, and you can confirm that. So, also if you are using Android, it's easier because there is a lot of tools on Android. You can intercept connection with man-in-the-middle software like SharProxy, HTTP Toolkit, Burp Suite. There is a lot. And also you can understand Android applications because Android applications are Java. And you can decompile Java easily with JDX. And also you can perform injections, so override live the behavior of functions, and you can modify the behaviors. And it's very useful when you want to understand how some headers or ID are generated, because from time to time they pop up from nowhere and you want to reproduce that and you don't know where they're coming from. So that's very cool stuff. Okay for you from now? Yeah? Good. So let's talk a little bit about how they architect that. So how it's working on Antibot. So there is 3 actors, the browser, the website, and the Antibot. Sometimes the Antibot is hosted on the website. Sometimes it's hosted on a dedicated website. It depends on the solutions. So first, the Antibot gathers a lot of information on the browser. So we talk about that, okay? Configuration, event, mouse movements, etc. They encrypt this information and send the payload to the Antibot. In return, the Antibot issues a cookie, and this cookie is used when you are navigating on the website. So you send this cookie to the website along your navigations. And now the website can ask with the server-to-server connections, so it can ask the reputation score, and based on this score, the website allow or deny us access. That's very easy. And the question is also how they encrypt the payload. Sometimes the payload is not encrypted, so bingo, yeah, we have this information. Sometimes they are smart, they say, yeah, let's use base 64 encoding. Are you using base 64 encoding? Yeah, to fool your colleague? Yeah, they like that, some of them. But let's be serious. The most advanced encryption system that I found is asymmetric encryptions. So how it's working? So first, the code of the Antibot on the browser, which is obfuscated, by the way, gather a lot of information. And they are compiling to that into a JSON with internal key. So it makes more challenging to understand the goal of each key. And after, the obfuscated code uses RSA symmetric encryption. So the public key is hidden on the browser code. So it's very difficult because it's obfuscated to get the public key. And it encrypts the payload. The payload is sent through a POST request to the server. And since the server holds the private key exclusively, this is the only actor that can decrypt the payload. And if you are using man-in-the-middle technique, you cannot understand the payload. So that's very advanced encryptions. So yes, as we saw, it is difficult to handle an Antibot systems. And also, we cannot use a lot of techniques for very unprotected website because it can be very costly. That's the problem. You cannot use proxy, anti-captcha, whatever, when you have no protection in front of you. It's useless. So let's adapt that. And there is some website with no protection. There is website with very basic protection, but there is also website with very hard protections. So to tackle that, we need an incremental methodology. So let me share with you one of the possible methodology. So we see how they are doing that now. We see how we can bypass the protections. So first, imagine that you have a scraper, a spider with a famous framework. Perhaps you know Scrapy. Who knows Scrapy? So Scrapy is a Python framework for web scraping used for 10 years. Open source community, so that's very cool. So you have your scraper, it can fill forms, go on the website, extract data, that's cool. But after 100 requests, it's not working. So perhaps it's time to tune the parameters. What you can do is to change the delay between requests. You can change the number of concurrent requests. You can also adapt headers. So there is a specific header called the user agent headers. It's a header from the client saying, hey, I'm Scrapy. So the website says, no, don't pass. So you can change that and say, no, I'm Chrome finally. But the problem is, if you are just changing this header, there is a lot of additional headers saying, no, you're not really Chrome, you're Firefox inside the Docker. So you need to adapt and be consistent. Also, you can use cookie, change the TLS version. I saw that, sometimes it's working. And also, you can adapt the order of requests, whatever. If it's not working, perhaps it's because you are using one IP address, your server IP address. So let's introduce proxy. A proxy is a system who will relay your request to the server. So for the server, instead of seeing thousands of requests coming from one IP address, he will see a lot of IP addresses sending few requests. So you will bypass the rate limit stuff. Also, you can start with data center proxy. They are fast, cheap, and reliable. You can use Scrap Proxy to start your own private proxy pools. And you can start with that. But if it's not working, it's perhaps you're not acting like a browser. Clearly, you're not executing JavaScript loading CSS. Remember that. So let's use some real browsers. But we don't have a display, we don't have a keyboard, we don't have a mouse. We are inside the Docker. So there is framework to do that. Basically, it's end-to-end framework used for front-end. So Puppeteer, Selenium, Playwright. So you can use this framework. And there is a bunch of plugins to bypass the fingerprint process. Now, if it's not working, it's perhaps because our IP address is very basic data center IP address. So we need to introduce more advanced proxy. There is a lot of type of proxy. First one is ISP proxy, Internet Service Provider proxy. So it's like data center proxy, but they are not using the IP address from the data center. Yes, you can bring your own IP address to a data center. You can buy them, rent them from a mobile carrier, internet box provider. You can buy IP ranges. So you bring that, and you will be mixed with real users. Also, there is residential proxy. So residential proxy is real user IP address. If I want to earn some money, I can share my bandwidth. And I will get euro for each gigabyte that I send. And that's where the residential proxy came from. And there is also mobile proxy or hardware proxy. So mobile proxy is basically provider having a lot of 4G key in front of the antenna, and they rent the 4G key. And you can buy yourself this kind of material. So I already bought that. It's not very expensive. And you have your own proxy farms. That's fun, to be honest. And here, so if it's not working, it's because the antibot detects automations. Yes, framework like Puppeteer, Playwright set a lot of JavaScript objects in the code, and the antibots can detect that. So you need to switch to a more advanced type of browsers, a real browser now. But a real browser needs a display, keyboard, mouse. So you can create this kind of virtual display, virtual keyboard, virtual mouse inside Docker with open source tool. And there is commercial solutions. And if everything is not working, there is full commercial solution. So it's called unblocker APIs. They will execute all the previous steps for you with machine learning, so they can adapt the parameter with machine learning depending on the website. Say, okay, please, on this website, on Amazon, use Windows with Chrome, whatever. And they adapt that for you. And sometimes you need also to solve some CAPTCHA. So there are very efficient CAPTCHA solvers with AI. And to be honest, you can install them for yourself. Imagine someone solving a big Google CAPTCHA, click on the bus hidden behind the red stuff, and the people, oh, where is the bus? And you see the CAPTCHA doing do that for you. It's very efficient. And please avoid human form CAPTCHA. It's not working and it's not ethical. So, you're good? We'll speak about architecture now. Yeah, so how we can architecture that? So if we translate the previous methodology into a schema, it would be the following ones. So let's say that we have our spider, very efficient, can collect the data. The first thing is that you want to scale, and you need to scale better organizations. The first thing, we need somewhere to store the data, so a database. We'll store all the collected data, but also the URL frontier. And the URL frontier is a list of URLs that you already visited and that you will visit. You need that. Also, you can use a broker to distribute the tasks such as RabbitMQ and some orchestrator. But as we discussed, we need to add additional IP address. So we introduce the scraproxy layer to manage all this proxy. The cool thing is it comes with cloud providers, and cloud providers offer free credit for startups, so you can create your own private proxy pools with dedicated IP, so you're not sharing that with another persons. And sometimes you need to introduce more advanced proxies, so ISP, residential mobiles, and scraproxy handles that in a second. And as we discussed also, we need to execute JavaScript. So we need to introduce headless browsers, but instead of adding a single browser, we add Chrome, Firefox, Edge, Safari, and also we use many operating systems. So it's a browser farms. The bad thing is there is no open source or free tool to do that, so you need to write it on your own for this part. So with this, we're ready to collect everything on the web. That's the best architecture for that. So take a pictures. You're good? Yeah? Perfect. So the thing is, I didn't disclose you the whole truth, to be honest, because the web is divided in two categories. So there is a long trail of websites, which are about perhaps 80% of the website, but they only drive less than half of the internet traffic. That's the issue. The other half, the 20%, drive the remaining traffics. And here, we are speaking about major e-commerce websites, social platforms, so you know them. And because they are driving a lot of traffic, they need the most advanced commercial anti-bot systems. And if we use the previous approach with this kind of website, clearly the success rate will be very, very low. So we need to have a more advanced methodology for them. And the best thing is to understand which signal they are monitoring one by one to correctly emulate them. So if we remind the previous architecture where I discussed about signals, the signals are embedded in the payload, okay? All signals, configuration, whatever, are in the payload and sent to the antibot. But the payload is encrypted. And the thing is that we need to trace back to the source code. But the problem is the source code is obfuscated. So what is obfuscations? Who know obfuscations? Yeah, some of you. So obfuscation is the art of rendering code incomprehensible. So you raise the hand, so I assume that you all have that one colleague who is a specialist as making the code incomprehensible. Yeah. But here, what I'm talking about is taking that to a whole new levels. When the code is obfuscated, you cannot understand what the code is doing and also why the code is working. And the deobfuscation process is not a mirror operations. Deobfuscation is the art of making a little bit sense of obfuscated code. So what we will do, before doing some deobfuscations, we will try to understand how obfuscation works. So first, we need a tool. A good tool is Babel. Who know Babel? Yeah, some of you, I assume. It's used on front-end framework to do minifications or reducing the size of the code. So Babel just take a string, which is your source code, transform it into a syntax tree. This syntax tree is your code, so function declaration, expression, whatever. And you do operations on this tree, so you switch the branches, you modify the node, and after you generate the real source code, so operation back. So let's jump into some methods. So we'll discuss about string obfuscation first, and after code flow obfuscations. So string obfuscations, here we can use what interpreted language allow you. So you can access to object method with object notations. So here we transform dot notation to string notations. Easy? Yeah, first step of obfuscations. But because it's easy, we just split the string, okay? So a little bit harder. But yeah, you can still understand string splittings. So that's why we will replace the strings. So we use random constant group at different places in the code with random names. But yeah, you can still understand what the code is doing if you figure out the meaning of the declarations. That's why we use encryptions. So here I'm using base 64 encryptions, very basic 64 encoding, sorry. So if you read the last line in red, you cannot understand the meaning of the operations. And remember that anti-bot systems are using far more advanced functions and hundreds of combined functions. So now let's talk about code flow obfuscations. So the first technique is code flow confusions. So here the goal is to exploit all the possibility of the JavaScript interpreter. And JavaScript is not Java. You know that. JavaScript is ugly. So yes, we can remove the code block and add it inside the conditions. But it's readable. That's why you inject that code. That code is called unexecuted, useless, but make it harder. And if you inject that in the previous conditions, it's more funny. And also, because it's not fair and funny enough, you will add scope confusions. So scope confusion is a very basic idea. It's a good practice when you are working with your colleague. Just name everything A. That's working well. If there is some scope collision, use B sometimes. So here we replace valid by B, but we also inject a constant inside, which is a B. So you don't know which B are we referring to. But of course you will inject 10 more variables, dead code, whatever. And there is a last technique, which is probably the most thickest method out there. It's code flow flattenings. So the goal is to transform a simple sequential code into a state machine. So it's back to the 80 with go-to-point in BASIC. Who did a little BASIC? Yeah, some of you. So BASIC, you had a lot of go-to-point. It was fun. And you did that with one state machine for all your code blocks. Clearly, it turns debugging a nightmare. So I won't go into the obfuscation because I've got 5 minutes, thank you. So let's go into signals. So imagine that you have deobfuscated the code. So to deobfuscate, you have the methods, and you select the right one until you can get some sense from the code. So there is 5 types of signals if you have correctly deobfuscated the code. First type, we already see that. It's about configurations, or we already see just before. The second set of signals is about automation detections. Yes, I told you that Puppet or Playwright, they let a lot of objects for interactions. And Antibot use this kind of signals to detect the framework. Also, there is more advanced set of signals which are about graphic renderings. So it involves drawing some graphic on an offline canvas or hidden canvas, so you don't see anything. They are doing some operations. And after, you are doing some hashes of that. And it's important to note that there is 3 main elements in rendering. So the browser, the operating system, and the GPU. So if you have Windows, Linux with a dual boot, and you are rendering on the same computers, you are rendering emojis. Emoji style are different from Windows to Linux. So hashes is different. Also, if you switch from Firefox to Chrome, hashes is different. Also, if you activate or not the GPU, hashes is different. So you can have a lot of information about that. The fourth set of signal is now the antibot trying to detect that you are reverse engineering the code. So they use some techniques. In JavaScript, you can get the source code of a native function with toString. So I'm not executing query selector. I'm using toString on the method. And I will get 2 important keywords, which are native code. But if you patch these functions, that you can do with polyfills, you will have a different answers, and there is no more native code. So that's how they protect and detect that you are doing some emulations. And also the last set of signals is about integrity controls. So they are doing a lot of checksums, so if you modify the previous value, don't forget to update the checksums. So that's all for the signals. What I would like to show you also is the next step of antibots that you can find. So the first thing, remember obfuscation code. You have the browser code, you get the obfuscated code, and you deobfuscate to get the source code. Good? Yeah, easy. Now they introduce virtual machines, like the Java virtual machines. So when you deobfuscate the code, you don't have the source code. You have the virtual machine plus the bytecode. But it's not swirly, it's not documented, it's undocumented and proprietary. And translating this bytecode to real source code is a pain in the ass. So thank you, Antibot Systems. So I hope that you enjoy the questions. Here are some open source tools if you want to do some reverse engineerings. So thank you very much. If you want to try download Scrapoxy, add some GitHub star, take some stickers, I've got some, and I will be happy to answer 1 or 2 questions. Yeah, I think I've got time for that. Yeah, 1 or 2 questions. Thank you. Questions? Or perhaps a quick Scrapoxy demo in 1 minute? Yeah? Do you want? Yeah, some of you? Okay. So let me switch that. So here I just started Scrapoxy, add a lot of connectors on Scrapoxy. You have a marketplace, which is more a list of connectors, and you can add address. Imagine that you want to use your own address connections. You just add your credentials here. Or I've got a lot of connectors running. So I've got on Dublin, I've got with Brighdata, I've got with Raybyte, and you can see the list of proxy and some everything. And the beauty also is you can see the coverage. So here I've got now 300 proxy all over the world just running from my computers. And you can use this pool to get new IP address, new information. So that's very cool. Imagine that you want to collect British websites. You don't use IP address from there. You use IP address perhaps from France, UK, or US or UK. And you can select that with proxy. He will choose the correct proxy pools. So you can start proxy from everywhere with different quality. Thank you very much. Have a nice conference, and I'm here if you want.